This webinar will go through the 2022 changes to building regulations. 3 building regulations are being updated. Document F relates to ventilation, Document O for overheating, and Document L for conservation of fuel and power. The full building regulations can be downloaded from the government website, but we've summarised the key changes for windows and doors, which can be downloaded from Smart Systems website on the Understanding Document L page. The building regulations are implemented on the 15th of June 2022. Any work which started before the 15th of June 2022 may continue as if the amendments haven't been made. For anything which is new build, it would normally go through building approval and planning permissions. Okay, anything which has gone through building notice, initial notice, full plans, amendment notice, or full plan submitted before the 15th of June, then they can continue as if the amendments haven't been made, as long as the work starts before the 15th of June 2023. In the Circular 01/2022, it describes what commencement of works would entail, but effectively it's starting the building work, so starting the foundations of the building or digging out for foundations. Okay, it wouldn't entail enabling works such as removal of topsoil or removal of vegetation. It's got to physically be starting the building works. Okay, the first building regulation which we're going to look at is Document F. Document F is split into 2 parts, where Volume 1 relates to dwellings and Volume 2 is for commercial work. Okay, in dwellings, the key change relates to trickle ventilation for windows and doors. And you'll see that the changes changed for trickle ventilation in the fact that in 2010, replacement windows should be fitted with trickle vents only if the windows being replaced had them. Okay, the most common interpretation for 2022 is that all replacement windows should be fitted with trickle vents, regardless of whether windows being replaced had vents in them or not. Okay. The areas for trickle vents has also increased. In 2010, the areas was 5,000 for habitable rooms and kitchens and bathrooms was 2,500 square millimetres. The 2022 regulations, this has increased to 8,000 for habitable rooms and kitchens and 4,000 for bathrooms. A few fabricators have expressed concerns about meeting those requirements. A typical size for 8,000 would be 2 trickle vents at just over 400 millimetres. So that would give you the width of the head extension required for a window. Okay, the sizes are listed in 3.15, but underneath 3.15 there's a note which says if it's not technically feasible to adopt the minimum equivalent area set out in 3.15, then they should have equivalent areas as close to the minimum values as feasible. So there's a requirement to try the best in terms of trickle ventilation. You don't need to meet those requirements if it's not physically or technically feasible. Okay. Additionally, in that paragraph, it says this may be demonstrated in any of the following ways. So point A is the areas. Point C is if other ventilation provisions, if they can be demonstrated to building control that they comply with the requirements of paragraph 3.2. If we look at paragraph 3.2, there's 2 requirements in there, which they should either meet the standard in the relevant approved document, which is the sizes which we saw earlier, or not be less satisfactory than before the work was carried out. So there's a requirement for ventilation to not be less satisfactory. So the ventilation needs to be higher than the work which was carried out. Okay, there might be a requirement, or there might be a way to demonstrate that to building control, that you don't need the full amount of ventilators on a building as long as the ventilation is improved from the original requirements on there. Okay, as we said, Document F is split into 2 parts. Volume 1 is for dwellings, Volume 2 is for commercial. Under the regulation for commercial, you've got a similar paragraph, but this time it's 3.6, and it's got a similar requirement on there. If it's not technically feasible, then try the best that you can. But the sizes are listed above there. The sizes have increased slightly. In 2010, the sizes for kitchens was 2,500. For kitchens, that's increased to 8,000 square millimetres. Okay, so 2,500 has gone up to 8,000 in 2022. But everything else remains the same. For floor areas less than 10 square metres, it's 2,500. For floor areas above 10 square metres, then it increases pro rata. Okay, but it's got a similar requirement on there in the fact that you can either meet the standard in the approved document or not be less satisfactory than before the work was carried out. Okay, so approved document F, trigger ventilators are required for all replacement windows. Okay, and you've got to meet the requirements based on the room areas on there. New build, I'd say you should consult the building designer because they will design the ventilation strategy for the building. Okay, but if we go back to 2006, in 2006, all replacement windows should include trickle ventilators. So the update in 2006 actually tried to push the requirement for trickle ventilators. And within a few months, there was an amendment to the 2006 following various studies. And the amendment said it would be good practice. So the previous regulations, it was good practice to fit trickle ventilators. And the requirement for trickle ventilators got removed in an amendment. We'll see if there's going to be an amendment in the future. But at the moment, it's looking like all windows require ventilators on there. So trickle ventilators required for all replacement windows, or not less satisfactory than before the work was carried out. Okay, so we'll see how that gets used as we go through. Okay, new build, I'd recommend that you consult the building designer. The next building regulation which we'll look at is a document O. This is a new regulation which has not been seen before, but it only applies to new build domestic. It doesn't apply to commercial and it doesn't apply to replacement work or extensions. It's only new build domestic. Sometimes on commercial work there'll be a contractual requirement, or there might be a sensible requirement to consider overheating, but at the moment it's not a regulatory requirement. Okay. Document O is split into two parts, or there's two methods to demonstrate that the building's not going to overheat. There's a simplified method and there's a dynamic thermal modelling method. Under the simplified method, there's two governing principles. There's limiting solar gains, which is all to do with reducing the amount of glazing in the property, and then there's removing excess heat. If we look at limiting solar gains first, limiting solar gains, there's a requirement on there and it's given as a percentage of the floor area. It sets the maximum amount of glazing allowed, and the maximum amount of glazing you'll see depends on whether it's a high risk or moderate risk location. High risk locations is generally considered to be central London. Okay, so the area shown in dark green above. Okay. The areas vary dependent upon whether the elevation is north, south, east or west. Okay, in London there's also a requirement to meet one of the three requirements below, which is external shutters or glazing with a G value of 0.4 or overhangs of 50-degree cutoff as well. Okay, so that's a requirement in high risk locations. The table at the top is for cross ventilation. Okay, there's also a requirement for buildings without cross ventilation, and cross ventilation could be for example, a corner flat. Okay, where a corner flat wouldn't have windows on opposing sides, and you'll see the requirements in terms of the maximum glass areas have been generally reduced in those locations on there. Okay, so depending upon the actual building, the actual maximum glass area ranges from 11 to 15% of the floor area. There's also a requirement for removing excess heat. Removing excess heat effectively tells you how much you can use as an openable window, and it says maximum areas, or the total free areas, need to be greater than one of the requirements on there, and it's expressed as a percentage of the floor area and it's expressed as a percentage of the glass area. Okay, as a floor area it's 6 to 12%, and as a glass area it's 55 up to 95% of the glass area. Also it sets minimum requirements for bedrooms as well, which you can see within the table. Okay, again you've got cross ventilation and without cross ventilation, and you've got high risk locations being London and moderate risk locations being outside of central London. So removing excess heat, the minimum openable free area ranges from 55 to 95%, and as a percentage of glass area it's 6 to 12% of the glass area. Okay, so if we just consider three examples, the first example will be the least onerous. Okay, so it's a low risk location, so it's outside of London. The largest glazed facade is on the north, so it's not got large amounts of solar gains on there, and it's got cross ventilation, so it's got windows on both sides of the property. In terms of limiting solar gains, the requirement is 18% of the floor area. Okay, so the maximum glass area can't exceed 18% of the floor area. Okay, in terms of removing excess heat, the minimal openable free area is 55% glass area. Okay, so at least 55% of the glass needs to be openable, and at least 9% of the floor area needs to be openable. Okay, so at least 9% needs to be openable in terms of an area. If we take the same building, but put the largest glazed facade this time to the west, okay, so again, it's a low risk location, but the largest glazed facade is this time to the west, and it's got cross ventilation, limiting solar gains. Okay, the maximum glass area has changed to 11%, and the minimum openable free area is 55% of the glass area again, but the minimum openable free area is 9% of the floor area. Okay, so you can see the requirements have just tightened up on there. Okay, but actually to achieve between 9% floor area and 11% glass area, then if we just look at the maximum glass area and the minimum floor area for openings, that means that 81% of the glass area, not 55% of the glass area, needs to be openable. Okay, so it means that we're starting to see a lot of openers and not many fixed lights on properties on there. If we move to the most onerous location, okay, so example 3 is a high risk location, so we're in central London. The largest glazed facade is to the south, and it's a corner flat, so it doesn't have cross ventilation. In this scenario, limiting solar gains, the maximum glass area is 11% of the floor area. The minimum openable free area is 95% of the glass area. Okay, and we need more than 10% of the floor area to be openable. So you can see we've got this requirement where 10% needs to be openable, but you can't have more than 11% glazed. So it's a real tight requirement on there. And actually, if we look at the practicalities of that, it's very difficult to achieve that. You'll see the openable free area. The openable free area should be larger than the equivalent areas. Okay, the equivalent areas should meet or exceed the free areas of the opening. The equivalent areas of the opening should be assessed by BSEN 131411 Part 1 or using Appendix D. If we have a look in Appendix D, there's a link to a calculator, and the calculator allows you to work out the free areas or the equivalent areas of the window. Okay, and the calculator is given by the link below. If we look at the calculator, it's an Excel spreadsheet where you can put in the width and the height and the opening angle of a window. Okay, so if we just take a typical example of a top-hung window, which is 1 meter by 1 meter, and it opens to maybe typically 50 degrees, then the equivalent area of that window is 0.787. So that gives you 78% openable area. Okay, if we can see we'll never achieve that 95% on a top-hung window which only opens to 50 degrees. If we have a look at another example and we open the window even to 90 degrees, okay, at a 90 degree opening, the equivalent area is 0.883 square meters. So the equivalent area is only 88% of the opening on there. Okay, so the equivalent area we're getting is only 88%. The requirement for London is that the minimal openable free area needed to be 95%. So even at 90 degree openings, we can't meet the overheating requirements on the simplified method on the glass areas. Okay, so that means that there'll be a lot of people which are using dynamic thermal modelling. Dynamic thermal modelling is using a computer program in order to assess the overheating requirements. So it's plugging in the design of the building in as a 3D model, and it will generate the overheating strategy for that building on there. You'll see, particularly on large glazed facades, okay, or buildings with large amounts of glass on there, the simplified method will be too constrictive, and a lot of people will be using the dynamic thermal modelling method. Document O applies to new build domestic. The implications which we'll see for windows is we'll see a reduction in overall glass areas, because obviously with the large amounts of glass it contributes to overheating, and we'll see mainly openers for removing excess heat, so not as many fixed lights, mainly openers on there. We'll see increased use of solar controlled glass. This is a requirement for central London, or one of the requirements for central London. Okay, but also for the dynamic modelling, I suspect that you'll see use of solar controlled glass to increase the glass areas. So the next regulation which we'll look at is document L, conservation of fuel and power. The limiting values and the notional values have been summarised in the document. Okay, and you'll see there's two parts to document L. They've been combined now. So the original 4 documents have been combined into volume 1 for dwellings and volume 2 for commercial. If we start by looking at existing dwellings, which used to be L1B, and the requirements now for existing dwellings. Okay, existing dwellings in 1995 was 3.3. That reduced to 2.2 in 2002, 1.8 with the introduction of energy ratings band D in 2006. 2010 we saw 1.6 and band C. At that point we changed the Alitherm 55 system, which was 55mm front to back, and we added 5mm to the thermal brake, and that's where Alitherm 600 was born. Okay. In terms of the changes to 2022, in 2010 it's 1.6 or band C. Okay, it's changed to a 1.4 or band B. Okay, and we'll see in terms of new systems on there. Okay, we'll introduce new systems towards the end of the presentation. Okay, but if we have a look at existing systems, in particular, say Alitherm 600, you'll see some of the options will be achieving a band C on there. So here I've got an outer frame which is ETC 614, a vent frame ETC 620, and a transom mullion ETC 634. Okay, and on that permutation it achieves a C rating, so it would be compliant to the 2010 regulations, but it wouldn't be compliant to the 2022 regulations, which require a band B. Okay, if we just add foam into the outer frame, okay, so here I've got ETC 614 with foam on there. You'll see with the right glass on there, it can achieve a B rating, and foam is just going on the perimeter of the outer frame, and it just reduces the heat losses around the perimeter of the window. Okay, so that's a B rated window out of Alitherm 600. If I take an example with our Alitherm 300, ETC 313, 321 and 333 can achieve a rating on there. Okay, so it exceeds the requirements of 2022, and that's using a glass on there which has got a high solar gain on there. So it's a 1.193 and a 0.74 glass on there, achieves an A rating. A window energy rating is given by the equation above. So it's on the left hand side you've got solar gains, okay, which is shown in red, and on the right hand side in blue you've got the heat losses. The solar gains relate to the G value of the glass. The heat losses, you've got U in that equation. You've also got AL, which relates to the air leakage of the window. Okay, an A rated window, the window which we've shown has got +2 on there. The actual solar gains is larger than the heat losses, so the window will have a net heat input. Okay, so it will start to warm up the building as opposed to cool down the building, so the solar gains is larger than the heat losses through a typical year. Okay, how we achieve that is by using high G value glass. Okay, so for overheating you want low G value glass, but for replacement windows using high G value glass allows you to offset your heat losses against your solar gains. And here we've got a centre pane of 1.2 and a G value of 0.74, which achieves an A rating on there. Okay, you'll see different sheets of glass will achieve different ratings. That 0.74 is actually Pilkington's K Opti White, which is their low iron glass. Saint-Gobain's glass would be Diamond, okay, which is a low iron glass. If I switch it to a normal iron glass, okay, Opti Float, then the G value decreases because it blocks slightly more of that solar gain on there. So the 0.74 reduces to 0.71, so only 71% of the heat is coming through the window. And because of that, it switches from an A to a B on there. So it needs low iron glass in order to achieve the higher G value. You'll actually see a centre pane of 1, because the G value is lower, doesn't achieve an A or a B rating on there. So it achieves a D rating on there. You'll only get an A or a B with the high G values on there. you'll actually see Pilkington's K glass with a 1.5 centre pane can achieve a B rating and an overall U value of 1.9. So it's compliant through energy ratings, it achieves the band B, okay, but it's a requirement of 1.4 or band B. You don't need to achieve both the requirements on there. So it's compliant even with Pilkington's K glass on there. Okay, you can check the specifications for a particular profile combinations and glass on the energy rating calculator. The energy rating calculator can be downloaded from our website, and it's a case of choosing the options within there. At the first, you need to check the type of the window which you're doing. So it'll do windows, casement, tilt and turn, top swings and vertical sliders. It will also do door systems, so hinge doors, double doors, bifold doors and patio doors on there. It's a case of picking the system, choosing the profiles and choosing the spacer bar and the glass used within there. Okay. It's preloaded with common sheets of glass, but what you can do is you can add your own user glass as well. So you can add custom glass configurations if the particular glass which you're using isn't in the list. Okay. We've got the energy rating calculator which can be downloaded from our website. Okay. If you're looking to add your own glass specifications, the glass suppliers tend to have their own software packages. So Pilkington's it's called Spectrum, Saint-Gobain is called Aluminium, and Guardian's calculator is called Glass Analytics. Okay, and each one of those will produce its own certificate on there, which you should be able to obtain from either their software or from your glass supplier. The certificates from Pilkington's have got the centre pane at the bottom, so that's thermal transmittance. In this instance, it's 1.04, and then it's also got total transmittance, okay, or G, and that's expressed as a percentage, so 0.49 G value on that sheet of glass on there. Saint-Gobain, okay, their centre pane is UG, which is on the right hand side, and the solar factor G is on the left hand side of their sheet on there. And then Guardians, it's similar format in the fact that they call it UG for the centre pane and solar factor for the G value of the glass on there. And it's the solar factor and the G value, sorry, the solar factor G value and the U of the glass, the centre pane, which affect your energy ratings on there. We've looked at typical double glazed sheets of glass using Planitherm Total Plus, and we've looked at the various different systems, okay, for the different configurations of windows on there. For window energy ratings, it's based on a standard design, which is 1230 by 1480. Okay, for a casement window, it's a side hung next to fixed. For a tilt and turn, it's tilt and turn next to fixed, or a top swing next to fixed. Or for a vertical slider, it's a vertical slider as shown in the diagram. Okay, the various different systems using double glazing are able to achieve a B energy rating, which is shown below. So Alitherm 300, 600, 800. Some of the larger systems, so Alitherm 700, because it's got larger sight lines on there, it doesn't perform as well in terms of energy ratings, and that's why it doesn't achieve an energy rating of B on there. So that's Alitherm 700, Heritage, Tilt and Turn, and Visalign. But generally speaking, with the right permutation and the right glass, you can achieve an energy rating of band B. Okay, so that's windows. For doors, it's 1.4, but it's not band B, it's band C for doors. Okay, so the requirement is band B for windows and band C for doors. Okay, the doors, they're based on standard designs again. So 180 by 2 meters for a sliding door. For a bifold door, it's 2.5 meters by 180. For a patio door or French doors, it's 2 meters by 180. Okay, and for a single door, it's 1230 by 180. Okay. If we take each one of those in turn and have a look at the systems, okay, so starting off with the sliding door, okay, Visaglide Plus and Slide 2000 can achieve C ratings with the right double glazed glass on there. So that's 1.2, 0.74 glass on there, it achieves a C rating. Okay, in fact, if I change the sash VG520 and include foams in the sash, then actually with the right glass it can just achieve a B rating on there. Okay, so you can see, dependent upon the glass, potentially you can exceed the requirements on there. The foam in the sash is foam into the polyamide chamber, which is just highlighted in yellow, and also a foam ACVG561 just underneath the glass. Okay, it's a 560 into the polyamide chamber and a 561 underneath the glass. Okay. If we look at bifolding doors, Visifold 1000 and 6000 can achieve a C rating. Okay, so the profiles which are listed there are DV14 as the outer frame and threshold, and the sash is DV23, and that's a C rated bifold door. If we switch the sash DV23 up to the 123, which is the slim sash, it can just achieve a B rating on there. Okay, so dependent upon the glass. So that's Visifold 1000, Visifold 6000 can achieve B's and C ratings on there. For double doors, okay, you'll see that, again the requirement is C. This time I've processed a heritage door with the outer frame W20015, W20015 threshold and a W20027 sash, and you can see it can just achieve a B rating dependent upon the glass again. So Visifold 1000, 6000 and heritage door can all achieve B's and C's on there. For single doors, the window energy rating equation changes. Okay, so whilst we said we can offset the heat losses against solar gains, for single doors, we only consider the heat losses, so only consider the right-hand side of the equation. The solar gains isn't considered, and the justification or the thinking behind this is a lot of single doors don't have glass in there, so they think there's a lot of panel doors, so it allows us to compare glazed doors with panel doors on there. Okay, and you'll see most of the existing systems, because we can't offset the solar gains against heat losses, don't comply in terms of an energy rating of band C on there. Okay, so what we've done is we've taken some sections and we've taken the Visifold 1000 and 6000 outer frame, which is DV17, and adapted it to produce DV19. And you'll see a DV19 doesn't have track inserts into there, so you can't put a bifold onto there. But for single and double doors, you don't need to put rollers into the system. Okay, so DV19 would be used for single doors, also double doors, but you wouldn't be able to use it on a bifold door. But the sizes, 51.5 is the same height as a DV19. Okay, and the depth is the same as a DV17. Okay, and with the thermal simulations on that, we can achieve a C rating on there, so it gives you a good thermal performance. And you'd use DV19 on all four sides of your door, so DV19 gives you C ratings. You'll see, because you're not considering solar gains, in this instance, it's the best sheet of glass in order to achieve that is a centre pane of 1.0, as opposed to the 1.2, 0.74 sheet of glass, which we were seeing earlier. Okay, so that's for existing dwellings. If we look at existing commercial, the requirements for commercial are a lot higher. They're 1.6s or 3s. Generally speaking, you'll be able to achieve a 1.6 with double glazing. As an example, we've got Visiglide Old on the left-hand side. Visiglide Old would require a centre pane of 0.7, but Visiglide Plus, in order to achieve a 1.6, you can do it with a 1.0 sheet of glass on there. Okay, so 1.0 or a good double glazed unit can get down to 1.6 on there. Okay, high usage entrance doors, the requirement for high usage entrance doors is 3. In the building regs, it's got a definition of high usage entrance doors, which is generally designed for robustness or powered operation. Okay, and or powered operation. So it's a robust door or it's a powered door are the main performance requirements. And it will be protected by an automatic closer. Okay, so high usage entrance doors will have automatic closers, so it tends to be your smart wall and your shop line systems on there. It also says protected by a lobby, okay, except where operational requirements preclude it. So you might not be able to fit a lobby in, say, on a shop, or it might be a breakout door to a classroom, where you can't obviously put a lobby on there. As long as it's got an automatic closer, it would meet the definition of a high usage entrance door. Okay, in terms of commercial, in 2010, the U value could have been calculated one of 3 ways, which is BSEN 14351, which had standard sizes on there, BR443, which referenced the GGF sizes for the BFRC models, and the specific size and configuration of the actual window was point C on there. Okay, you'll actually see in the 2022 regulations that's changed, and you'll see there's a note there which standard configurations should not be used for commercial windows. Okay, it's only if they are similar to dwellings that you'd be able to use the standard configurations of a siding next to fixed, which comes from BR443. Okay, so because of that, you need to calculate the U value on the actual configuration of the window which you're doing. In order to help on that, what we've done is we've provided a facility within the estimating software where you can click the U button on there, and that will calculate the U value for the quote which you've got in your job on there. It's a case of entering the quote number in the box and clicking on the export button. Okay, as an example, this is a quote with 11 items on there. The first item is a smart wall screen, 2 meters by 2.5. Okay, and you'll see the U value on that is 1.4. It will do the breakdown for you based on the glass on there. It's a case of entering the glass center pane on the first sheet. Here it's a center pane of 1.0 and a psi value of 0.3035, gives an overall project U value of 1.5. On the smart wall screen, it's a 1.4. Okay, the next screen is a 1.2. If we look at a door with side screens on there, it's a 1.6 overall using 1.0 glass. If it's a single door with a side screen, we've got a 1.5 overall. As a single door on its own, it's coming in at 1.9. Okay, so we're meeting the requirement of 3. Here we've got a 1.6 with a side screen, and with a sliding door with a side screen is a 1.8 on there. So you can see you can work out the various different U values across the job. Okay, that was for existing. If we move on to new dwellings and new commercial, there's values, again, we're seeing that 1.6 and 3. So the same as commercial existing, new dwellings and new commercial is 1.6 and 3. Okay, you'll also see there's limiting values, okay, or notional values, which are the notional values which are 1.2 for domestic and 1.4 for commercial. And that's done through a calculation which is either SAP for domestic, which stands for Standard Assessment Procedure, or SBEM is the Simplified Building Energy Model, which calculates the CO2 for the entire building. The notional values I think would be best described as default values. These are starting points for a building designer to work out the CO2s for the entire building. Okay, there will be notional values for the windows, the floor, the wall. It will even consider the efficiency of the heating system on there, and that will go through a calculation. Okay, so this is a SAP calculation which considers the U values, the various different elements of the building. It also considers the efficiency of the heating appliances. Okay, so the overall U value is the overall energy efficiency is based on the heating system as well, which is used on there. The notional values, like I say, as a starting point. Once you've got the CO2s for the building designer can offset different elements. So they might choose to upgrade the walls and downgrade the windows, as long as they don't exceed the limiting values, where the limiting values are 1.6. Okay, so the designer can choose between a value of 1.2 or up to 1.6, depending on what offsetting they've done. If they upgraded the walls, they can offset the windows. They might choose to upgrade the windows and downgrade the walls. 1.2 is a starting point for that calculation, and the limiting value is 1.6. Okay, so in terms of the changes, okay, it's been summarized in the technical update document on there, but since 1995 you can see the U value has gone from 3.3 and now we're looking at 1.4s, 1.2s and 1.6s. Okay, so we're dependent upon the requirement on there, and that's all been summarized on that table on there. As a typical sheet of glass, okay, a single glaze sheet of glass has a center pane of 6. A double glaze can achieve around a value of 1, and a triple glazed unit can achieve a center pane of around 0.5 in terms of the best sheets of glass are available on there. Okay, so to summarize, okay, in summary of document L, the implementation is 15th of June, and potentially for new build work which has gone through planning prior to the 15th of June, there's a 12-month transition period which takes us up to the 15th of June 2023. For existing domestic, we can generally comply with double glazing under the energy rating. So an energy rating of B for windows and C for doors. So B for windows and C for doors. For new build, limiting values are generally achievable using double glazing. So the limiting values for windows and doors are 1.6. For new build, notional values would tend to achieve triple glazing, and we'll have a look at the new system. So there we've got Visotherm just shown on there with a triple glazed 36mm unit. Okay, but the notional values are 1.2 for domestic and 1.4 for commercial, and then for doors again it's 1.2 and 1.9 for commercial. Okay, in terms of finding out more information, there's under the fabricator section you can click on Understanding Document L, and that will take you to a page where you can download the technical update which summarises the changes on there. As well as that, we've got a copy of the presentation which you can have a look at in terms of a PDF, and you can download the window energy rating calculator to work out the energy rating and the U value of windows. That will produce a certificate for you. So for window energy ratings, it will give you a certificate showing the ABCs on there. Okay, and for U values, it will tell you a certificate for the U value, and they're based on standard designs which you can use for domestic. Okay, for commercial, you're looking to do the U value based on the actual design and configuration of the window for you. Okay. So that's a summary of the building regulations update, document F, document O and document L. So F for ventilation, O for overheating and document L for conservation and fuel and power. Like we said, you can download the full building regulations from the government website. Okay, but the next thing which we're going to have a look at is the new systems to introduce in accordance with document L. In part 2 of this presentation, we'll have a look at product development and new systems. Okay, starting off with the VisiFold door and finishing with the Heritage 60 door. Okay, so we're starting off with VisiFold door. VisiFold door, as we've already said, we've introduced a new iframe which is DV19, where DV19 is ideally suited to single and double doors. It uses the same hardware as the DV17 and the other VisiFold systems. Okay, but effectively DV19 is already intended for single and double doors. We've said we get better U values and better energy ratings with a slim sash, which is DV123 and DV126. Okay, we are introducing some new sashes, which is DV220 and DV221. Okay, this is a square and a curved sash, but it's got a different beading arrangement, which allows us to use a quick glaze bead arrangement on there. The quick glaze bead comes already with the gasket in situ. Okay, so the gasket UN3160 with a G means it's got the gasket in situ. So when you buy it, it will have the gasket in place, so you don't need to wedge on site. Okay, currently that's available in black and white and KL005, but that will start to be available in other colours in due course. Okay, so that's the UN3160G. If you're wanting it to be in mill finish, you'd order it without the G, or if you needed other colours on there, UN3160 without the G is just it's exactly the same bead, but without the gasket already in place for you. Okay, we've said there's two new sashes, which is DV220 and DV221. Okay, those are also available with the gasket on there, so the E gasket. So all the glazing gaskets, if you order the profiles with the G in place, would be available pre-gasketed on there for you. Okay. In terms of dropping the gasket in and the bead in, it's similar to just dropping in a normal bead. It's a case of applying pressure to the front of the glass just in order to compress against the E gasket, and then using a nylon mallet would simply tap the bead in place on there, and that would be tapped in with the gasket in place. Okay, so any time in terms of cleaning the glass after you've been wedging isn't required, and you don't need to do any wedging after the bead's been tapped in on there. Okay, we also supply glass adjusters, an ACDV295 as a glass adjuster, and that means that you don't need to deglaze if you need to readdress any towing and heeling on there. What you've got is you've got an Allen key which can be simply tightened up, which effectively changes the towing and heeling on there. So you can either add more packers on there by increasing the tightness of that Allen key, or remove packers by rotating an anti-clockwise position, and then you can effectively tow and heel, and that can be installed on the corners of the glass, which means you don't need to remove the beads. Okay, if you do need to remove the beads, say if you need to remove the beads because of a glass breakage, or if you've got a unit breakdown, you can remove the beads with the gasket in place, but the gasket, it behaves like a wedge gasket in terms of removal, and what you can do is you can pull out the gasket using a flat blade screwdriver. Okay, and then you can pull out the gasket, which gives you a bit more space to rock the bead if you want to, but it's a case of rocking the bead and putting a deglazing tool into the gap on there. Okay, so it's nice and easy to remove the gasket if you need to. If you're for whatever reason you're having difficulty getting the gasket back in place, you can use a traditional wedge, and you can use traditional e-gaskets into the system as well. So you don't need to use the captive, the co-extruded gaskets if you're wanting an extra space, say if you've got an oversized unit on there. Okay. The bead, it's available in 4 different sizes. So you've got 3160G, 4179G, and then you've got a 3166 and a 3168. The 3168 is a flat back bead, which is ideally suited if you're wanting to do triple glazing into the system. Okay, if we have a look at glass thicknesses, that can accommodate up to a 45mm unit, and with a 45mm unit, the 45mm unit made up of 446.8 with S1 plus on the 4mm and S3 therm on the 6.8, so you're achieving past 24. You can get down to a centre pane of 0.57, and with a centre pane of 0.57 on your standard designs you can achieve a 1.2. Okay, so you can be compliant to building regulations on the notional values with triple glazing on there, and that's on a standard design window which can be used for domestic. Okay, gasket has been tested for impact testing, so it's had a hard body and soft body impacts on there. It's gone through past 24 security tests. It's gone through weather testing. It's also been tested for UV, hot and cold shrinkage testing on there as well. So it's gone through all the various different testings on there, and it does allow us to do a very quick glaze bead into the Visifold door. Okay, we've also got a similar beading arrangement going into the Aluminium 400 door and the Aluminium 400 window. So Aluminium 400 is a new system where it's got a door system and a window system with a quick glaze bead on there. If we look at the door initially, the door, as we said, it's got a quick glaze bead. It does open in and open out, single and double doors. It's got a quick glaze bead. It's been kite marked, and it's got 3 different types of lock on there. You can do a key operated lock, an auto engage lock, or a lift lever lock on there. So the key operated lock is similar to the Sabinco key wind locks. Auto engage is a slam lock which is engaged with a magnet, so it throws the locking devices automatically, and a lift lever is the locking devices are thrown using by lifting the lever on there. Okay, the system, it will accommodate up to a 40mm infill panel, so it will do panels with doors on there, and there's both a stepped and a flush finish to the system as well. If we just look at the step door initially, the step door, there's an outer frame which is ETD 410, and that's the same outer frame whether it's open in or open out, and it's a 4204 for open in and a 4205 for open out on there. But you'll see the bead arrangement is the same bead which we saw in the Visifold, which is a quick glaze bead, and with a 1.0 centre pane we're achieving 1.4 on a standard design. Okay, so we can get very good U values on there. It's also got a section which with a flat back bead where if you drop in a 0.8 you can get a 1.2 overall, okay, on standard designs. Okay, there's also another sash which is ETD 424. That's a flat sash, so the detail on the outside is slightly different, and really we'd anticipate that you'd be using that if you're putting panels into the system, and if you're putting panels into the system it creates a nice flat detail on the outside, and with a 0.8 centre pane, as we said, we're down at 1.2 on that section. Okay, so that's the stepped system, which has got a slight step on the outside. There's also a flush door system, which is ETD 412, ETD 4202 and ETD 4203. Okay, and again there's a flat section within there which can accommodate the flat look on there. Okay, but then again you've got similar thermal performances to what we saw earlier. Okay, so it's a door system. It's also a window system, and the window system takes the same bead which we're seeing in the door and in the bifolding door system. So it's a quick glaze bead system. Okay, it's been tested as well, so it's gone through the kite mark testing, and typically we can achieve a 1.4 or we can achieve a band A depending upon the glass which you're using on there. Okay, so we've got some very good performances on there. In terms of sections, the outer frame is ETC 4110, or if you're locked in a stepped outer frame, it's a 4112. Both of those outer frames, the 17mm front to back and 42mm deep, the difference is just purely where that step goes up to. Okay, on the 4110 it goes right up to the top, and on the 4112 it's just shouldered on the rebate line. Okay, you've got a transfer mullion, which is 4130, and then an internally or externally beaded sash. You'll see externally beaded, it uses the same quick glaze bead as what you're using on the inside as well. So nice, quick and easy to glaze on there. You've got a UN3160G. Okay, in terms of the system, that's a traditional window system. In the same system, you've got a flush options as well. So the outer frame is slightly different for a flush look. It's an ETC 4115 and the transfer mullion is a 4135. You'll see it's still 70mm front to back is the outer frame, but the step is accommodated because the shoulder on the inside has been reduced to accommodate the step on the outside, and the outside is all flush, and you're using exactly the same exactly the same sash, whether it's the flush sash or the traditional fashion on there. Okay, so that's your flush Aluminium 400 flush. If we look at glazing on there, with a 1.0 centre pane, you're down at 1.4 on standard designs, and then with a 0.6 centre pane on a triple glaze unit, you're exceeding the notional requirements and achieving 1.1 overall. VisiGlide Plus is going to be introduced with a VG920 sash, and you'll see that the beading arrangement is very similar to the other beading arrangements in the fact that it takes a quick glaze bead, which allows you to install a gasket and bead at the same time. It'll accommodate a triple glaze unit, and with a 38mm unit broken down into a 4.6.8, that allows you to achieve a centre pane of 0.69 with an overall U value of 1.3 on standard designs on there. The Visotherm door is a new door system and it's a new window system. Okay, so Visotherm door and window system. Again, we'll look at the door first and look at the window. The door system has all been designed around thermals. Okay, the front to back dimension is 80mm. Okay, so it's the Aluminium 400 was 70mm. This is 10mm larger than the Aluminium 400. Okay, so it's got 10mm larger thermal breaks, and typically that's around 0.1 of a U value better. You've got UL210 being the outer frame, and then the open in and open out flat sashes are 224, 225. And then you've got chamfered sashes, which is 226, 227. Okay. It's got excellent thermals being 80mm front to back, and you'll see with a triple glazed unit, which is 44.8, it can achieve an overall U value of 1.0 and an A+ energy rating on there. Okay, so you can get really good thermal performances across the system, and that's simulated as a single door 1230 by 1480. For the window, you've got UL010, which is 44.5mm, and you've got UL011, which is 49mm, so a slightly deeper outer frame. You've got internally beaded chamfered or flat sashes on there, and then you've got two different transfer mullions, UL030 and UL031, and that accommodates, again, it's 80mm front to back, so it couples with the Visotherm door very nicely, and again, it produces very good thermals on there. It'll accommodate up to a 48mm unit using UL068, and with UL068 I've got an overall U value of 0.9, and that U value is achieved with a 444 sheet of glass on there with 16mm cavities. Okay, so and it's simply a sheet of glass with two skins of S1 Plus or two skins of Planitherm 1 if it's Saint-Gobain. Okay, and like I said, with a 0.5 centre pane, you can be down at 0.9 overall. If we look at the energy rating for that sheet of glass, the energy rating is a C rating, and that's because that sheet of glass has got a low G value. So whilst it's got a low centre pane, it's also got a low G value. Okay, generally speaking, I would see the Visotherm window being aimed at the new market, whether that's new commercial or new domestic, where really you're striving for the best overall U value. If you're wanting an energy rating, if you go for a triple glazer unit using two skins of Opti K Glass S or Planitherm Total Plus, then the G value is higher, and that would achieve an A+ rating on there with a triple glaze 0.8, 0.61 G value on there. Okay, so that's the energy rating for the Visotherm window. The Heritage door, we said we can achieve a B's and C's on a double door, but at the moment it's only achieving a D rating on single doors. and at the moment the heritage door is 47mm front to back. In order to achieve a C rating on there, this system was going to be stretched to 60mm front to back, so it's going to be increased in its depth inside to outside, and that will allow us to achieve a C rating on heritage doors on there, and that would be using a centre pane of 1.0. Okay, and that overall energy rating is an A rating if potentially on a triple glaze unit. So subject to testing, we can drop in a 36mm unit into the heritage system, and with a 36mm unit we could do a 0.7 centre pane, which gives us an overall U value of 1.2 and an A rated heritage door when assessed as a single door. Okay, so that was looking at the facade systems, going from Visifold door to the heritage door. Okay, also we'll have a look at some of the newer systems which are also being introduced, which is Aluspace, a decking system, and Solumbra, a pergola system on there. So starting off with Aluspace, okay, we've already seen heritage has been stretched to 60mm to accommodate a larger thermal break. Aluspace takes away the thermal break out of the heritage system, and really it's intended for when thermals aren't required, so for internal screens and partitions, which might be used in domestic or commercial scenarios. The doors within the system, we can do hinge doors. Okay, and the hinge door is very similar to the heritage hinge doors. In fact, it shares a lot of the accessories and the components, shares the hinges from the heritage door system, and it's got a lock plate like the heritage door system. So a traditional hinge door, very similar to a hinge door. You can do pivot doors, okay, where the pivot is a top pivot and bottom pivot, and it will rotate around 90 degrees around that pivot on there, similar to say a shopline or a smart wall door, but the pivot's obviously a lot smaller, intended for internal applications on there, and the height of those screens can go up to 2.5. And you can do a pivot door without the side screen, so it might be that you've got walls adjacent to it and you're just wanting to put a pivot door straight into the building structure. As well as pivot doors, we've also got sliding doors, where the sliding door is a top guided mechanism, so there's no threshold to step over, there's no obstructions to step over, and the door is hung along the top of the system on there, and it allows us to open the door without encroaching into the space either internally or externally. And it means that you can optimize the space, particularly to offices or for things like wet rooms in domestic applications on there. The system is being designed around single glazing. If we look at a 6.8 acoustic laminate, the acoustic performance, the RW could be up to around 36 dB. With an 8.8 laminate, acoustic laminate, the RW could be up to 38. And for the best performance, we're looking at a 10.8 acoustic laminate, where the RW of the screen could be as high as 40 dB, particularly useful for, say, office space where you might need to put acoustic requirements across there. Okay, as well as screen work on the inside, we've got Soldeck, which is a decking system. It's a low maintenance anti-slip coating on there, but effectively it's an aluminium decking system, which is obviously non-combustible, being made out of aluminium, and it's very easy to install. There's two different sizes of decks on there. You've got 120 or 140, okay, dependent upon the size of which you're after. Okay, and the assembly is very easy. It takes a clip which is an ACSD 100. ACSD 100 just goes between the two decking planks. You offer the planks together, and then you access the fixing through the drainage gaps between the planks on there. So it's very easy to install. On top of the decking, we can install a Solumbra, which is a pergola system. On the photo there, it's showing a glazed arrangement where you've got sloped glazing around a square ring beam. You can also do slats, and those slats would rotate 120 degrees. So with the slats open, it allows the sunlight through, and then with the slats closed, it behaves like an interlock, where it engages the interlock and it drains the slats into the ring beam. So both the glazed arrangement and the slat arrangement drain into the ring beam, and then you've got concealed drainage down the pillars. You can operate the slats using a remote control, but you can install rain sensors, particularly say for commercial applications. So it might be a bar or a restaurant, and the slats will automatically close when the rain starts, which will help protect the area underneath. Okay, you can install LED lighting into recessed strips on there, and it creates a very nice arrangement on there. There's a range of other systems as well, so a continental collection, which includes deco walls, staircase, gates and fences, railings, roller shutters, sunshades and Venetian blinds. All of these are available, okay, across the group. Okay, and if they're interested to you, then you can contact your area sales manager and we can provide you details and have a look at introducing these products into the UK. Okay, so we looked at the facade systems, okay, going from Visifold to Heritage, and then we've looked at internal systems being Aluspace and external systems being the Aludec and Solumbra, the Pergola system. Alongside the development in terms of product development, we've been developing on site. In 2005, we dropped in the offices and the warehousing. In 2010, we dropped in 2 extrusion presses and a horizontal paint line. In 2015, we dropped in a 3rd press and a vertical paint plant. In 2017, added a 2nd vertical paint plant and storage. And 2018, we added in tooling and a door production plant on there, which was phase 5. Okay, the most recent additions is going to be phase 6. Okay, under phase 6, we've got a panel paint line which is adjacent to the door production, so it means that we can paint the doors all on site in the same building without having to move between buildings on there. And also as part of that, we've got 2N, 2B dropping in a 4th extrusion press into the area near to the existing extrusion presses. So that gives you an idea of the expansion of site, but also the product development which we've got. Okay.